This then is the sample assessment foundation tier triple chemistry year 11. So the first question asks you to circle what kind of reaction taking place. You've got magnesium strip and copper sulfate, so that's going to be displacement, okay? Put a tick next to the mass of the beaker. Its contents after 1 hour is going to be exactly the same because the bung is going to stop anything escaping, okay, so any gas that's escaping. Put the metals in reaction, okay? Repeated it using sodium sulfate solution, so the copper sulfate, no reaction took place. So if there's no reaction, that means sodium is the most reactive, okay? We know magnesium is more reactive than copper because it's displaced that. So we've got sodium is the most reactive, then magnesium, then copper. There's a bit of information here on the table, and it says, use the information to calculate the percentage increase, okay? So that's something that you would have done in numeracy in year 10. Percentage increase in the mass of the nail after they've been exposed to water and oxygen, okay? So that's the start, that's the end, so do the change over the original, okay? And then that would give you 12 over 28, 6 over 14, 3 over 7. I just did that hoping it would work up to a number, it didn't, and then in the calculator I then worked out to be 42.8%. Okay, you're going to have to times your answer by 100. Little diagram then of electrolysis. The first question, which most people would have missed out and not got the marks for, draw an arrow for where each ion is going. So we've got O2 minus going towards the positive anode, Al3 minus going towards the negative electrode. Balance it out. You've got 2 times 2 will give you 4, so that means you need 4 aluminiums, okay? 2 times 2 will give you 6. What times by 2 will give you 6 is 3. Main reason this process is expensive, requires loads of electricity. Next one then says, what is the name given to the negative electrode? That is the cathode. If you were struggling, remember the little anagram I taught you. Panic, positive, anode, negative is cathode. Describe the test used to identify hydrogen gas, lit splint, squeaky pop. 34 grams of water is broken down into its elements, 4 grams of hydrogen is produced, calculate the mass of oxygen. We know it's just the electrolysis of water, so we're only going to have hydrogen and oxygen. So 36 take away 4 will give you 32. Circle an anomalous result and explain why it's anomalous. It doesn't fit the trend. So you've got 3840, okay, doesn't fit the trend. If that's, so you get rid of it and calculate a mean that's more accurate. Nice then, 2 marks, only 2 marks though, which seems a bit unfair to plot a graph and then it's like a line up, a line down. State what conclusions can be drawn from the graph. The optimum temperature for reaction to occur is 40 degrees. After that, the temperature increases and the rate decreases. Right, a word equation for reaction taking place. You've got glucose plus your yeast catalyst will give you ethanol plus carbon dioxide. Name the type of catalyst produced by yeast catalase. Loads and loads and loads of information. The majority of this information is from year 10, okay? That's year 10, that's year 10, that's year 10, okay? So, Caroline carried out 2 tests to identify a compound she thought to be iron sulfate, okay? Give the expected observations for the tests that were carried out. Add sodium hydroxide solution. If she thought it was iron, she should have got a green precipitate. There was actually no knowledge here, which was quite nice. It was just reading the table. She added then barium chloride. She should get a white precipitate. Okay. Gareth carried out 2 tests to identify the second compound. His observations were, so yellow flame test, go up the top. That's going to be sodium. Okay. Add hydrochloric acid, bubbles are formed, that's going to be carbonate. So the compound would be sodium carbonate, okay? The positive always goes first, so positive before negative, just in terms of naming. A pupil was given a jar containing ammonia gas. Describe the test that could be carried out to prove it was ammonia. Damp red litmus paper will turn from red to blue. Name what's going on here. That's an acid plus a base gives salt plus water. Give the chemical formula for ammonia chloride formed during the reaction. So ammonia chloride is NH4 positive, Cl minus. Okay, so they balanced out. So then on here, we're expected to give the molecular formula of propane. So propane's 3 carbons, 8 hydrogens. Looking at the kind of increase in boiling point, there was no trend to it, so I went for 0. Just as being a quite number that's quite in between them two. Okay, fill in the fire triangle, really nice question. Oxygen, fuel, heat. A beaker of ethanol caught fire in a laboratory. Suggest how the teacher would extinguish the fire. Give a reason. So fire blanket, remove oxygen. Okay, we wouldn't use something like water because it's ethanol. It could catch fire. Carry on catching fire. Information then about methane. It said the breaking the bonds of methane is that much. Okay, so they gave you the reactants already. Then it asks you to work out the energy that would be in the products. Okay, so CO2 looks like that. So there's 2 bonds. You just times that together. They'd already told you had 4 OH bonds. That in total gives you 3320. Okay. Nowadays they draw that out for you. Okay, you would not be expected to draw it at GCSE. And then reactants minus products gave you minus 680. Loads and loads and loads of hydrocarbons up here, or homologous series. Name 2 alkenes. Alkenes are things with double bonds, so E and D. 2 alcohols will have OH, so G and C, and a polymer would be F. Give 1 compound that could undergo polymerization. Well, it could have even been D or E. I put E, double bond which could be removed. And then it says, ductane is an alkane with 12 carbons. Calculate the number of hydrogen atoms present in a molecule of ductane. So you use the symbol CnH2n plus 2, so that would be 12. 2 times 12 would be 24, plus 2 would be 26. And that will give you the number of hydrogen atoms. 2 graphs, and if you notice this question kind of comes up quite a lot. Temperature rise neutralization for both of them would be 25 because that's where the peak is. So that would be 25 take away 23 would give you 1.5, okay. Stronger acid A because it's large temperature rise. Point of an indicator. Indicator changes colour to show when enough acid is added. Show the point of neutralization. Lots of information here. You've got to kind of read through it as best you can. Which one of these statements is a scientific description of the role of a zinc oxide in no sun cream areas comparing the effectiveness of sun creams? No sun cream is a reference substance and zinc oxide is a factor being tested. Which one of these questions were Rebecca and Jonathan trying to answer? How does the protection of sunscreen compare with others? Why were the samples placed between 2 plastic sheets, same thickness? Answer 2. Okay, the black dot indicates on the no sunscreen that the sun has hit the no sunscreen. Okay, zinc oxide should be able to reflect the sun, so it can't be that one. Okay, so them 2 would be knocked out. Okay, and this one should be dark, so it had to be that one. Okay, give a balanced simple equation for the reaction between sulfur dioxide, oxygen, gives you sulfur trioxide. Okay, so there were 2 marks there for just reading the question and putting the chemical symbols in. It's a 2 and a 2. Okay, again, another percentage increase. Looking at the change, so it goes from 68 to 56. Okay, take them away from each other, divide by the original, would give you 35. 1 mole of sulfur trioxide reacts with sulfuric acid to give oleum. Again, nice easy question. If it's going to be 1 mole, it's exactly the same going through. What would happen if you added concentrated sulfuric acid to copper sulfate? It would turn from blue to white, turns powdery. Sulfuric acid is a dehydrating agent. Nice kind of question here, showing ionic bonding. So transfer skills, okay, over, transfer electrons from here, okay, to the oxygen. The new electronic structure would be 2,8 and it would be minus 2 because it's gained 2. Each of these, their new electronic structure would be 2,8 and it would be plus 1 each of them, okay. Nice then covalent bonding in water, okay. Loads and loads of information to read about what kind of melting and boiling points conduct electricity to different compounds have. Give the letter A, B, C or D that does not have a structure listed in table 1. It would be C, okay, because C is a good electrical conductor whenever none of them are, okay. If you're considering it, then that one would be that one because it does conduct electricity but only when molten or dissolved. Use this model to explain 3 properties that are typical of metals: conduct heat, electrons move to transfer heat, conduct electricity, electrons transfer electricity, malleable layers which slide.